Welcome to A-Star Science, part of our GCSE Must Know Chemistry series. Today we're going to be talking about the reactions of acids and bases. Let's first start to remind ourselves what an acid is. You have strong acids, and these are substances that fully ionize. So for example, hydrochloric acid will have a single arrow and will dissociate or ionize into two ions. We know it fully ionizes because it has the single arrow. You could also have weak acids. These partially ionize. For example, we can have a weak acid like ethanoic acid, which is a type of carboxylic acid, and that has a reversible arrow, and that's going to partially ionize. So you can see the H plus ion, and it's going to partially ionize, and we know that because it has the double reversible arrow. So all acids, for the purpose of GCSE, they contain the H plus ion. And that's how we know that the acids, they generally tend to taste sour. And they'll have a pH which is less than 7. Now let's look at bases and what bases are before we go over the reactions of acids and bases. So a base for GCSE contains the OH minus ion, which is called the hydroxide. Bases tend to taste bitter, whereas acids taste sour. Bases tend to taste bitter, and they have a pH which is greater than 7. We call those bases. Now, an alkali is a soluble base, meaning it's a base that dissolves in water. So hydroxides, for example, soap, which we all know tastes bitter, dissolved in water, that's a form of a base, a soluble base. So we're going to look at some of the reactions that are needed to know for your GCSE. So now we've covered the definitions of acids and bases. Let's look at some of the reactions. The first important reaction is when you have an acid which reacts with a base. And that's going to yield a salt plus water. A salt, by the way, is just another name for an ionic compound. And ions, as we know, ionic compounds have a positive cation, so that's a positive ion, bonded to a negative anion. So an example of a salt, of course, is table salt, aka sodium chloride, which has a positive sodium plus and a negative chloride ion. So let's look at an example of this reaction. We could take hydrochloric acid plus sodium hydroxide, and that's going to give us salt, which is the sodium chloride, plus water. We check to see if it's balanced or not. We have 2 hydrogens on the left, 2 hydrogens on the right, 1 oxygen, 1 sodium. That looks to be pretty much balanced. So that's a reaction. This reaction, we call it a neutralization reaction. And the reason why is that the products are neutral now. pH 7. All of the acid and base would have been used up, and now the solution will be neutral. Let's look at the second reaction. An acid plus a metal oxide. And that's going to yield salt plus water. So again, this is a form of a neutralization reaction. And that means that a metal oxide acts as a base. It's insoluble in water, so it's not an alkali. It acts as a base. So let's look at an example. We take hydrochloric acid plus sodium oxide, which is going to be Na2O. And that's going to give salt, sodium chloride, plus water. We check to see if it's balanced or not. So it looks like here we're going to need 2 sodiums. That means we need 2 of these. And now that looks to be balanced. 2 hydrogens on the left, 2 sodiums on the left, 2 sodiums on the right, 2 chlorines. Everything looks to be balanced. So the salt, as you can see, is made up of the cation, in this case is sodium, and the anion, in this case is chlorine or chloride. So an acid plus metal oxide yields salt plus water. Let's look at reaction number 3. Reaction number 3 is an acid plus a metal. And this will give us salt again, plus hydrogen gas. We're going to use G as a state symbol. So an example we can use is hydrochloric acid plus magnesium. So it's going to form a salt, magnesium chloride, Cl2, because magnesium has a 2+ charge, plus hydrogen gas. Let's see if we can balance that. I think that's all we need. And now it's balanced. We can see our salt on the right, the magnesium chloride, which is a metal plus non-metal. So acids plus metals yield salt plus hydrogen gas. Let's look at reaction number 4. An acid plus a metal carbonate. So that's going to contain the carbonate ion, and that's going to give again a salt plus water plus carbon dioxide gas. So you would see fizzing. So if we took some hydrochloric acid and we added it to a metal carbonate such as limestone or calcium carbonate, that's going to give calcium chloride plus the water, plus carbon dioxide. This one be a, let's look at to see if we can balance it. But there are 3 oxygens on the right, 3 oxygens on the left, 1 carbon on the left, 1 carbon on the right, 2 hydrogens, so that doesn't work. So we need to put a 2 in front of that. Now that gives us 2 chlorines. So that appears to be balanced now. So an acid plus a metal carbonate yields salt plus water plus carbon dioxide. And as a result, you would see fizzing or effervescence in this particular reaction. So those are the main 4 reactions of acids and that you need to know. Now there's one more that doesn't involve acids, but I like to include it. So let's look at that now. And so we're on number 5. And that is the alkali metals. Now, when they react with water, you get a metal hydroxide plus hydrogen gas. So an example of this would be, for example, sodium, which is an alkali metal, plus water. That's going to give sodium hydroxide plus hydrogen gas. We can balance that by putting a 2 there. That means we need 4 hydrogens. So I think I can put a 2 here and then a 2 in front of the sodium. And now it is all balanced. Now this is important because the sodium hydroxide, as we said earlier, is a form of a base. In this case, it's soluble. So we call them an alkali. We know that because it has the OH minus ion. So these are the main reactions of acids and bases that you need to know for your GCSE. They come up as important, especially when you're doing the required practical for making salts, because that's where you will react an acid like sulfuric acid with copper oxide. So sulfuric acid plus copper oxide will make copper sulfate plus water. Why? Well, as we said earlier, an acid plus a base, metal oxide's a base, yield a salt plus water. And this again is a form of a neutralization reaction. Please make sure you like and subscribe. Leave a comment. Let me know if there's a video you'd like me to do, and I'll be happy to do it.